Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we've got another great topic for you today. As a matter of fact, we're closing out our series on OCS360. Here's today's topic: using any OCS with OCS360. Well, I think you can see from our thumbnail that we've actually changed our intended topic for today. Originally, we were going to show you how to use micro OCS with OCS360, but we've decided to expand that to any OCS. And to explain why we've done that, before we even get into the breakdown of today's topic, let's bring in my colleague who's joined us for this entire series, Don Clutterbuck. So Don, thanks for joining us again. How are you today?
Good, good.
Okay, so the first question, the big one, what's behind the topic change for today?
Well, up until now, we've been saying that OCS360 can only work with the prime and canvas units, but coming this summer, the micros will be supported with a data rate plan that could work with the micros.
Awesome. So that's really good news. So the customers, by this summer, it won't matter whether they have micro or canvas or prime, all of those will support the OCS 360 service. So any limitations on the micro side?
Yeah, right now the limit is 250 variables per minute, which means the micros will only work right now with the silver plan.
But
If
really,
you need more,
Mhm.
then you need to go to the gold and the platinum plan.
Got it. And upgrade to a prime or a
Just
canvas unit in that scenario. So
correct. Yes.
exactly. But if you think about it, we're talking about the type of application. If you think about the type of applications that the micro is typically used in, pretty straightforward stuff. 250 variables per minute doesn't sound like much of a limitation.
Right. It should handle anything, especially if time your publish rates at different rates to handle the different types of data you want to send up.
Awesome. Yeah, so that's great news. So since we're not going to be exclusively talking about the micro today, it sounds like to me we're probably going to be talking about some of the older OCS products, maybe the original XL series and that sort of thing.
Correct. There's a lot of customers out there that I have talked to that says, can it be used with the older generation controllers? And unfortunately, it can't. But they also don't want to upset their process and take something out, put it back in, troubleshoot a little bit, and so forth. So by using a canvas unit or a prime unit, you'd be able to use it as a data concentrator to get the data up. We have one beta customer that had 5 micros that was doing that. So they got a Canvas 4 and just use it as a data concentrator up. But again, using that data concentrator can limit or can gather all the information from all the OCSs in the plant, and then you just have to worry about one plan going up to OCS 360.
And if you've got a scenario where the data subvolume, fits within, let's say even an OCS 360 Platinum plan, that for an entire site or a subgroup at a site, then that's an architecture that makes a lot of sense.
Correct. Yes. And using CAN and Ethernet communications, it's fairly easy to share information between controllers.
And that's what we're going to be covering today, is whether you're talking about adding a canvas unit to one legacy OCS, or whether you're talking about adding a canvas or a prime unit as a concentrator for a whole series of units. That's what we're going to be reviewing with customers today. Okay, so Don, we've wrapped up our OCS 360 series. I want to thank you for joining me throughout.
It's been a pleasure. Just go to the site and try it and let us know how it works for you.
Awesome. Take care, Don.
Thanks.
Okay, so here's our breakdown for today. Just like we have for the last several weeks, we're going to do a quick one-slide review of OCS 360. For those of you just jumping in now, we're going to talk about what OCS models directly support OCS 360 and how you can connect other models that don't directly support OCS360. We'll talk connecting those products over Ethernet, and we'll talk connecting those products over CsCAN, because not every Horner product ever produced has Ethernet, but they pretty much all have CsCAN, and we'll have plenty of demonstrations throughout. All right, here we go. Okay, so what is OCS360? It's a new cloud service from Horner, which makes it about as easy as you can possibly get to push data from a Horner controller to the cloud using a special free version of MQTT. OCS360 is supported by Prime and Canvas and will be supported by the Micro in the future, and offers 3 core functions: data recording for up to 5 years, dashboarding, and alarm annunciation and notification, and we'll be adding additional functionality as we go. And you can always try out OCS360 for free for the first 90 days. Your credit card will not be charged until after the first 90 days. Okay, so now we're diving into today's topic. What OCS models directly support OCS360? Well, as we've pretty much told you for this entire series, it's Prime and Canvas, which support completely all 3 plans with OCS360, and which we just told you today, the Micro OCS this summer will be supporting the Silver plan. So you can see there on the screen, the X4, the X7, and the X10, models A and R. Not the X2, of course, because the X2 doesn't even support Ethernet at all. Okay, so the good news for this week is you're going to have Micro OCS direct support for the Silver plan starting this summer. Okay, but what about older models or other models that aren't covered on that previous slide? The XLE and XLT, of which we've sold tens and maybe even 100,000 of those units over the years. What about the XL series, the original XL series? We're not talking about Prime. We're talking about the original XL series, or maybe the RCC series, which is a fine micro PLC, but it's not included on the previous slide with direct support for OCS360. So how are these products that are working great in the field right now, and of which you have no desire to replace or even a need to replace, how can you get the data from inside these controllers onto OCS360? And what about some other controller from Horner, maybe back to even the first generation stuff back in the late 90s, more than 25 years ago? So the good news is, if you've got a Horner controller that's working great, and it at least has a CAN port on it, and we started putting CAN ports on our products back in 1998, there's a really, really good chance you're going to be able to utilize that product and get its data onto OCS360 using the techniques we're going to show you today. Okay, so now for the remainder of our topic today, we're going to talk about how you connect these other OCS models that don't directly support OCS360. How do you get the data from those controllers up to OCS360? Well, what you can do is what Don talked about in the open or in the interview there, and that is you can use any Canvas or Prime controller as an OCS360 gateway. Can be either, and it can be any model in the series. All right, these are powerful products. They have excellent data throughput, so there won't be any issues in terms of aggregating data and getting the data sent to OCS360. These devices support the Silver, the Gold, and the Platinum plan, so regardless of how much data you have, up into the limits of the Platinum plan, the Canvas or Prime unit that you use as a gateway can handle that data just fine. Okay, now, in terms of interfacing with those existing products, maybe at your facility, then the preferred way to do it is over Ethernet, and we're going to be showing you how to do that first. That's the easiest and the preferred method. However, if you have units that don't have Ethernet, but they do have CsCAN built in, then we're going to show you also how to grab the data from those controllers and get it up to OCS360 through your Prime or Canvas unit acting as a gateway. Okay? And although we're not going to show you how to do it today, if you've got one of those very few OCS models that don't have LAN or CAN, you can use your serial port to get the data up to OCS360, again, through a Canvas or Prime controller. So again, we're not going to show you how to do that today, and that should be an extremely rare case. All right, so now we're going to tell you the steps involved for connecting to OCS360 over Ethernet. Again, that's the preferred approach. And kind of grayed out there in the background, you can see an OCS360 Gateway, which is basically just an X5 Prime or maybe a Canvas unit. Again, any size will work from either the Prime or the Canvas series. However, we are going to talk a little bit more about the 5-inch and the 4-inch sizes because those seem to work the best. Okay, now let's go ahead and talk about the steps involved here. All right, so the first step, when you're configuring the controllers that have the data that you want pushed up to OCS360 through your Prime or Canvas unit, the first step is to make sure that their Ethernet port is configured appropriately. Maybe they had an Ethernet port on there, but it had never been configured or never been used. Well, you're going to be using it now if that's the case, so you need to make sure that at least the IP address and the net mask have been properly configured. The next thing you're going to want to do in your existing OCS is you're going to want to enable Modbus TCP server. Sometimes it's called Modbus TCP slave in older versions of Cscape, but basically you want to enable Modbus TCP server. All right. Next, you want to determine which of the variables that already exist in these OCS controllers that have been installed in the field for a number of years. Which of those variables do you want to publish to OCS360? Because it's important to understand the variables that are important for your application. And then once you've done that, next what you're going to do is you're going to use move blocks, more than likely, to map those existing variables. Okay, that if you're talking about register-based advanced ladder, it's probably, those variables are probably contained in R, M, and T registers, but you're going to effectively create a little bit of new logic to map those existing variables over to a consecutive area of %R or %AQ register space. So once you have consolidated those variables into one bank of registers, whether those R's or AQs, that will allow the connection between the OCS acting as the OCS360 gateway and these legacy controllers over Ethernet to be able to very efficiently move the data, and then ultimately it'll show up on OCS360. Now let's talk for just a minute about that fourth step there, where you're moving data from existing variables or existing, registers over to a continuous bank. So I'm going to recommend that you use either an existing open bank of registers somewhere in the range of R1 to R9999, or if those by chance happen to be full or you just don't have a bank of continuous registers, maybe you need 32 registers or 64 registers or 50 registers, and maybe there just isn't a continuous area in %R register space in that range for you to allocate for the consolidation of your variables. Well, in that case, you should take a look at AQ memory types, because really there is no difference between AQ and R from the standpoint that they're both retentive, they're both word type. And one thing about %AQ is that in most applications, you're probably not using more than 20 or 30 AQ registers. So there's a really good chance that there's a continuous area in AQ memory that's available if you want to use it. Okay, so that's something to consider if you happen to have a register map or a %R register map that's pretty full and certainly doesn't have a block of registers big enough for you to use. Okay, so that was just something I wanted to mention there. All right, so we've talked about the 4 steps in the existing OCS controllers. Configure Ethernet, enable Modbus TCP server, and determine the variables you want to publish, and then get those all consolidated and mapped over to an open area of register space. That's really the target or the task involved in the existing OCSs. Now, one thing to keep in mind, even though we're using Modbus TCP, don't worry, you're not going to have to do any kind of conversion between Horner register space and Modbus register space or anything like that. We're going to be using something called native addressing. So that is when you're setting up the Ethernet communications between the two OCSs that are doing the data exchange, or there could be multiple OCSs doing the data exchange, you're going to be using native OCS register types of Rs or AQs. So you don't have to worry about that. All right, next let's talk about the steps you need to take in the OCS that's acting as an OCS360 gateway. In other words, the prime or the canvas controller on my screen here. This is an X5 prime is the example I'm using for that. Okay, so here's the steps involved in the OCS360 gateway. Okay, first, you need to configure the LAN like you normally would, but because this particular device is talking over the internet to OCS360, in addition to the IP address and the net mask, you need to configure the gateway and the DNS server. Okay. Next, you're going to be configuring the Modbus TCP client side of the communications with the OCSs. Okay. And if you're using variable base advanced ladder these days, then you're going to create some variable arrays to grab the Modbus data, okay? Or if you're still using register base advanced ladder, that's no problem. In that scenario, you're going to use a block of Rs or AQs, okay? Whatever you prefer. All right. Then what you're going to be doing after the communications is all configured is you're going to be taking those blocks of data that you're grabbing over Modbus TCP from the existing OCS controllers, and you're going to map those over to variables that are ultimately going to be pushed to OCS360 by this particular OCS, all right? And you can use either move blocks to do that, or if you're using variable-based advanced ladder, you can just use the mapping column to map those variables that you're created that are going to OCS360 to the same registers where the data came in over Modbus. And then, of course, you can check that checkbox to say, all right, push that data or include this particular variable with the OCS360 group that is being pushed to the cloud. All right. And then finally, step 4 is you're going to go on to OCS360 after you've, created your account and those sorts of things. And you're going to add the OCS, which is acting as a gateway, as a device on your OCS360 account. Now, we're going to show you all of these steps, but we're going to stop before we get to step 4. And that's because we've had lots of videos in this series that have talked about getting started with OCS360. So if you need to know how to get started with OCS360, how to create your account, how to add a device, those sorts of things, go back to our Getting Started with OCS360 video, and you can see all the steps involved in that. All right, so that's what we're doing with Ethernet. Let's go ahead and demonstrate this now. Here we are on the bench. Let's start from here. On the left, what we have is an XL7, which is representing, let's say, a machine that's a little bit older. It's not brand new. It's based on an XL7. It's an epoxy-matic machine. Throughout this series, I've kind of simulated this epoxy-matic machine. And so this machine isn't that old, but it is a few years old, and it is based around an XL7, not a prime. So it doesn't have direct support for OCS360. So if we want to get this data up to OCS360, we need to use another unit, either a canvas or a prime, as an OCS360 gateway, and that's what we're doing here. On the right, we have a canvas 4, which is an excellent OCS360 gateway, or can be used that way. Now, one thing I didn't mention in the slides is I did go ahead and put the standard OCS360 status and clear certificates button and those sorts of things that I have included with all of my OCS360 demo programs to date. So that will allow us to, make sure everything's working as it should be. Okay, since this device, the one on the right there, the canvas, is going to be reporting data to OCS360, that status is useful information. Now let's look at the Cscape side of things, starting with our legacy machine. Okay, now let's go to hardware configuration and make sure our Ethernet is set up properly, because that's a requirement here, since we're going to be serving up this information to the OCS360 gateway. So we just need to make sure our IP address and net mask are configured. The others could be, but the only ones that have to be are IP address and net mask. Those are configured. And we have to make sure that Modbus TCP server is checked. Other than that, that's really all the Ethernet configuration that we need. Okay, so we're good there. The next step is to take all the data that we want to report to OCS360, whatever that data is, and get it all gathered and mapped to consecutive locations in memory. Now, it's very possible that if this machine was set up to be able to have customers access data from a SCADA package or something, this work may already have been done. They may already have a lot of the key variables already mapped to consecutive registers so that there's a standardized Modbus map that was available for customers with SCADA systems or with control rooms, those sorts of things. But if that work hasn't been done, then that needs to be done. Now, this particular machine isn't that old, so let's say that it is using variable-based advanced ladder as its standard program. So let's go to our program variables and take a look at the global variables, all right? And let's find the variables that we want to report, okay? Now, basically, here they are here, okay? So just like the other epoxymatics we've been dealing with, okay, we've got pressure, temperature, rosin level, hardener level. Notice how I have these all mapped to, in this case, I chose %R, in the range of %R9001, a bank of registers there, R9001 to, let's say, R9032. So 32 consecutive registers max. I don't need that many, but let's say I have that many allocated. And I'm mapping these variables in that range, okay, so that they're all easily accessible. All right, now these are global variables. There's also some retained variables. Let's go take a look at those. We've got a few retained variables that we want to report as well. So here they are: machine on, temperature, set point, and batch count. So these are all mapped into consecutive areas. So let's say this was some added mapping I had to do to this machine because it wasn't there before. It may have been there before, but let's say I added this to get everything in a nice consecutive area. So what that basically means is that all the data that I'm going to want to report to OCS360, that I want our OCS360 Gateway, Canvas 4, to grab from it, is all nicely located from R9001 to, let's say, R9032. In reality, it's only 9001 to 9012, because the last one I've mapped here is this batch count, which is double integer starting at 9011. Notice also that my Boolean variable, I mapped it to an individual bit within a word, okay? And so if I had additional Boolean variables I wanted to report, they could go in 9001.2, .3, .4, .5, etc. Okay, so that's basically all I have to do on the legacy machine side. Make sure Modbus TCP is configured. Make sure the variables that I want to report are in a nice contiguous area in register memory where they can be retrieved. Now let's turn our attention to the gateway unit. What programming have we done in the gateway unit? Okay, so I'm switching here. All right, I'll temporarily close the variable table. All right, so here's a screen I created. I mentioned the fact that I created kind of the standard status screen for OCS360, since this device is directly talking to OCS360. Okay, and then let's go right to the configuration of the network. Okay, under hardware configuration. Okay, so we go to LAN 1. Now, this device is directly talking to OCS360, so we need all of these configured. Okay, not just IP address and net mask, but also gateway and DNS server, because this device is accessing the internet. Okay, all right, so that's configured. Now down here, okay, is where I've configured Modbus client. Okay, you can think of it as Modbus TCP master, but Modbus client. Okay, and let's take a look at the configuration there. Okay, under network, I have trimmed down these timeouts to be much smaller. Okay, so half a second should be plenty for a timeout for a factory type response from the other machine that I'm talking to, my legacy epoxymatic through the XL7. I've set my retries to 2, but the big thing is set this timeout down to a reasonable level. 500 milliseconds should be fine, or maybe 1 second. Okay, update scan is how I've got it configured, and then I've got my reacquire time set at 5 seconds. It could be set shorter, but this is effectively how long the controller, the OCS360 Gateway, will wait for the other controller to respond, half a second. It'll retry 2 more times, so a total of 3 times. If all that fails, it'll wait 5 seconds and repeat the whole thing again. Okay, so in addition to that, and polling just as fast as we can by setting this to 0, we've got, I've assigned a Modbus TCP disable bit, okay, which I have the ability to use in the future if I want, don't have to. And then this is very important here. I have a status block of 4 consecutive 32-bit values that I can use to monitor the health of the Modbus TCP status. Okay, so that's good there. All right. Okay, and then let's go back into there, into devices. And this is where we're going to list all the devices that we are talking to. Now, so far, I've only got one. Okay, and I'm calling it Machine 4B. That's what I'm naming that particular epoxymatic, that XL7 we've got on our bench. Okay, I've got its IP address here, and I'm going to be using native addressing. Okay, that's key because that means I can directly access the %R values in that controller without having to worry about any kind of translation to Modbus variable types. Okay, I've got a disable bit that I can use here if I choose that I've assigned, and then I've got a couple of status words I've assigned as well. So this is a good basic configuration I would recommend for any of your devices that you're going to be polling. Okay, now finally what we have under the scan list is we have, let's take a look at it here. Okay, we've set up a single item on the scan list. All right, and we're grabbing data from this machine, which is what we named, of course, the epoxymatic based on the XL7. And then under device register, because we use native addressing, we can directly access from the memory of that XL7, we can directly access the %R memory location all the way up through R9999 is available. So we map to 9001 and on. If you remember correctly, we had 12 consecutive registers, could be as many as 32 or even more if you had to have it, okay? And then locally, this data, these 12 words of data locally are going into this array right here. Okay, so that's where the data is going, this array right here. All right, and then we're doing a polled read-write. Why are we doing a polled read-write? Because this gives us the ability to send data back down to the XL7. So we can configure, if we choose, we can configure subscribed data in addition to published data from our gateway here and actually send data back down to this XL7. Okay, so that maybe a temperature set point or something like that. If that gets changed on OCS360, that data gets passed to the OCS360 Gateway, which is our Canvas 4, and then that information will get written back down over Modbus TCP to our XL7 epoxymatic. So that's why we want to use polled read-write here, so we can have the option of having both published and subscribed data. Okay, all right, there we go. So that's what we have here. All right, now the next step, which is an important one, is to take that data, that 12 words of data that's coming into that array, and to allocate that data over to individual variables that we're going to push to OCS360. Now, because this is variable-based advanced ladder, we can do all of that from the program variable window. Okay, so let's go to the program variable window under global variables. Now, these are all under global variables because this data is updated live over Modbus TCP or over Ethernet. So we're getting this data live so it can all go under global registers. We don't have to worry about the retained aspect of it. If we want them to be retained, we can. But since every time we're powered up, we're just continuously getting this data live, I didn't put it under retained. All right, so I'm going to scroll down here. The first thing we're going to highlight is that array where the data is all coming into, okay? And that is coming in right here, okay? So that's the array that is in our Modbus TCP client configuration. It's 32 consecutive words is what I've allocated. We only are filling in 12 of those, but we have 32 words allocated to this array, and we're going to map that array somewhere in local register space. it does not have to be at the same location as the other XL7. We're talking about the local memory here. Okay, so I chose to put it in R1001. That's where all 32 words are going. Okay, so R1001 to R1032. Now, I created individual variables, okay, and these names should be familiar, machine on, temperature, pressure, etc. But I put an indicator on the back of the variable name for the machine it was coming from. In this case, it was machine 4B, so I put a 4B on the end of it because I could have a whole bunch of machines that I'm going to be creating variables for and sending data to OCS360, okay? So I've created all these variables, and then for each individual variable, I've mapped it to the appropriate location in that bank of registers that came in from the XL7. So the first bit of the first word was my machine on variable, so I mapped it there. The second word was an integer value which represents the temperature. I mapped it there. The third word was a real value. That third and fourth words together represent a real value starting at 1003. So you can see what I did here. Basically, I just made sure I mapped them appropriately, created the appropriate variables, mapped them appropriately, and we're good to go. Back to the bench, and let's see how things are going. So over here on the right, you can see our publishing count is counting up. Okay, so that looks good. And we've obviously got data on our epoxymatic. Let's go take a look at OCS360. Here's where I have added my gateway here, my Canvas 4 gateway. All right, so if we click on that, we can see the telemetry, the latest telemetry data watch. So here we go. Here's all of our data, and you can see there are our variables that we're reporting and all their current values. All right, everything looks good. All right, so that everything's working beautifully. So we are, and I guess we can go ahead and change some data on the unit and verify it's going to change here. Let's change our set point. Let's find our temperature set point. There it is. It's currently at 55.9. Let's make a change on that on the bench. Okay, so our set point, we just changed it to 56.2. Now back here, and we can see, boom, it's already changed. Now I have set my update rate to 3 seconds. I did that for demonstration purposes. In a real application, you of course have to manage how often you're publishing data. You can publish it as fast as once per second, but you do have to manage the total amount of data that you are sending up to OCS360 so that it fits within your silver, gold, or platinum plan. Okay, very good. So that is a demonstration of using Ethernet to grab data from a legacy machine into a Canvas or Prime unit that's acting as a gateway and getting that published to OCS360. Next, let's talk about connecting OCS units that do not have Ethernet, but do have CsCAN built in. And that's pretty much every OCS we've ever sold has CsCAN built in. They don't all have Ethernet. Okay, now the process is somewhat similar, okay? So let's kind of go through that real quick, all right? You do need to configure each OCS that is in the field of which you want to push data from it. You need to make sure the CsCAN node ID is unique, okay? Because it needs to at least be different than the OCS360 Gateway. And if there are other OCSs also on that same CsCAN network, of course, every OCS on the network has to have a unique CAN ID. And there's some additional CsCAN configuration items we'll talk about in detail here in a minute. But just like with Ethernet, you need to determine the variables you want to push to OCS360, the ones that are important. You need to use move blocks or mapping to map the variables to consecutive registers. Again, R's and AQs are usually the easiest to work with, just like the Ethernet step. And then you're going to use netput heartbeat and netput word instructions in the logic programs for those OCS controllers to send the data out to the OCS360 Gateway, which is then going to forward that data to OCS360. So those are the 4 steps. Now let's take a look at some details on some of the steps. Okay, so in addition to making sure that every OCS on the CAN network has a unique CAN ID, there's also a CsCAN configuration for you to go through. And there are really 3 parameters there, beyond node ID, of course. Network required, and really all the network required checkbox does is just controls the OK LED on the OCS. So in other words, if an OCS that has network required checked is not communicating successfully over CsCAN, then the OK LED on the OCS will turn off, even if that's just a virtual LED on the system menu. Number of CAN IDs, the default is 1, is the next parameter to talk about. So as long as the OCS is pushing no more than 32 words of data to the OCS360 Gateway to then be forwarded on to OCS360, then the default of 1 is fine. If you do have more than 32 words to send, 32 words of variables to send, then you'll need to increase that number of CAN IDs appropriately. So for every CAN ID you add, you'll have an additional 32 words. Now, the way this works is, let's say the CAN ID is 10 for the device you're configuring, and you need, let's say, up to 96 words of data. You're going to allocate 3 CAN IDs, and the CAN IDs, if the base ID is 10, will be 10, 11, and 12. That'll be how that will work. In most applications, 32 words of variable data for OCS360 is usually plenty, so you probably won't need to increase the number of CAN IDs. The last thing to talk about is max packets per scan. Okay, the default is 1. I would recommend that you just bump that up to 8. What that means is you'll be able to broadcast as many as 32 words of data over CAN from your OCS in a single scan at one time without having to queue up the messages and sending 1 out per scan on 8 consecutive scans. So I would bump that up to 8. If you have, let's say, 64 or 96 words of data to send out, which is, again, an unusual case, then you may need to bump that up more than that to 16 and 24, for instance. But generally, set it to 8 and don't worry about it. So that's kind of the detailed CsCAN configuration beyond just making sure you have a unique CAN ID for each controller. Next, we're going to have to add net put heartbeat. Again, this is down to step 4 now. When we put our net put heartbeat and net put word instructions in logic to actually get the data over CsCAN to the OCS360 Gateway. Okay, so the net put heartbeat instruction, that's just to send out a signal once per second that basically allows the OCS360 Gateway to know that everything is going well, that node is online. So that's a good idea to have that logic in there. And it's going to be effectively what I've shown there on the screen, and we'll review that in the demo as well. And then when it comes to the net put word instruction, there's a couple different ways you can do that. You can do your net put word so it's based on change of state, or you can set it up like I've shown here on the screen, where you effectively send out the data once per second over CsCAN, which will effectively be received by the OCS360 Gateway once per second. And then regardless of how much dithering you have on any analog signals or sensor signals or anything else, you're going to basically be pushing the data out there over CsCAN using this net put instruction once per second based on the logic I'm showing you here. So that's what we're showing when it comes to getting the data out there. All right, so this is what you need to do on the OCS units that have been installed in the field that are going to be sending their data off to the OCS360 Gateway, so the OCS360 Gateway can then get the data parsed and off to OCS360. So again, back to the OCS360, steps required when you're using CsCAN to talk to the legacy controller. First, make sure that you've got a unique CAN node ID for your OCS360 Gateway. That's pretty straightforward. And adjust the CsCAN configuration. We'll talk about that in a second. You're going to have to add similar instructions to your logic, although this time they're going to be net get and of a heartbeat and net get of the word data to receive the CsCAN register data that's being broadcast by the other controllers. And then you're going to use move blocks or mapping to create variables that you're then going to push to OCS360 from the CsCAN data. So pretty straightforward stuff. Let's go into some more details on the OCS360 Gateway side when we're talking CAN. Starting with those same 3 additional CsCAN parameters to configure. Again, I think you can pretty much just match the configuration that you used on the OCSs that are pushing the data to the gateway. So just leave those the same with the same comments there. Okay. Also, you're going to use net get heartbeat instructions instead of net put heartbeat so that you can verify that the nodes that are connected are up and online. And what you're going to do is you're going to use a net get heartbeat instruction, 1 per the OCS controllers that you're getting data from. Okay, so on this screen capture here, I'm showing that we have 2 OCSs that are sending out their heartbeat that we're also going to be receiving data from. So I'm showing 2 net get heartbeat instructions, and I've got a couple of OK coils assigned to each of those controllers, or 1 assigned to each of those controllers, so we know that they're OK. And then when it comes to getting the data from the controllers, I'm showing a couple of net get instructions, 1 per controller in this case, where we're receiving in 32 words. And because this is a variable-based advanced ladder program I'm showing you here, we're using input variables that are array-based, word type input variables that are array-based to store the data that's coming in over the network. Back to the bench for our CAN demonstration. So on the left there, we have what we're calling a mini, or an epoxy mini, which is a epoxymatic machine, but it's a mini version. So it's based on an XLE controller. And this particular XLE controller is CAN only, doesn't have Ethernet on it. Of course, the newer XLEs, you do have Ethernet available as an option. But we're going to show you how to take the data from them and get it up to OCS360. So on the right there, we still have our Canvas 4 that's acting as an OCS360 gateway. It's still publishing data to OCS360. And we can use the same gateway to publish data from devices that are Ethernet capable, and as well as ones that are CsCAN only capable. So in this demo, we're doing both. Okay, so let's take a look at the program for the Mini. Let's start from the hardware configuration and take a look at our CAN config for CAN 1. Okay, so we're going to set this for 1 CAN ID, 8 max packets per scan. That should work in most cases. If you need more than 32 words per node, you can bump this up to 16, 24, etc., while you bump this up to 2, 3, etc. Okay, but that's what we want to set. The big thing is to get this increased so that we can send more CsCAN data on a per scan basis. Okay, so that's all the configuration we need to do for CAN, making sure, of course, that this device has a unique CAN ID as compared to the OCS360 Gateway or any other node on the network. Okay, now let's go take a look at the logic here. So we're broadcasting a heartbeat once per second. That's so the OCS360 Gateway can tell if everything's up and running by monitoring that heartbeat. And then here we're sending out data, in this case 12 words. Remember, we could send out up to 32 words. We're going to send out 12 in this case because that's what an epoxymatic has to broadcast. And we're setting it up so that every second we have a one shot that enables this net put function block, which then sends the message out to the field. Now, the other way we could do this would be strictly with change of state. So we could choose to click this on change of state instead, that checkbox there, and then it would send on change of state. But if you've got analog values that are dithering or any of those sorts of things, you may not want to do that. So there's a couple different ways you can do that. I chose for this example to make it send out once per second. Okay, so that's all the logic that's required in the in this slave unit, this little epoxy mini. But now to finish the job, we either need to move our variables into this space here. Now, if I was using register-based logic. I wouldn't have an array here. I might have R9001, for instance, as the input for this put block, and I would be sending, in that case, R9001 through R9012 out over CsCAN. And then I would have other move blocks that were moving, or basically copying, the variables that I want to broadcast over CsCAN into R9001, R9002, R9003, etc. So that the data would be populated, this data here would be populated with copies of the variables that I want to send over to the OCS360 Gateway. Now, because this is variable-based logic, I do all my work from the program variable table, just like before when we showed you the Ethernet example. If we scroll down here, we can see, here we go. First of all, the CsCAN words out, these 32 words, let me go ahead and show you those here. Okay, CsCAN words out, these up to 32 words, but we're sending 12. Okay, that is mapped to R9001. Okay, so if this were variable-based logic, we'd have if this were register-based logic, we'd have R9001 here as our input. And then here are the individual variables mapped to different portions of that block of registers. Okay, just like we did with Ethernet. It's really identical. All right, so that part is all the same. So that wraps up the logic in the Epoxy Mini, which is my unit that does not have direct OCS360 access. Now let's take a look at the program in our OCS360 Gateway. Okay, all right, let me close this down here. There's a screen I have. Let's start, though, by taking a look at the CsCAN data here. Okay, so this is where we're actually going to receive in the data from our other node. And for every OCS that's out there sending their data over CsCAN to this OCS360 Gateway, you're going to have these two rungs. Okay, so first of all, we're getting the heartbeat. Okay, we're checking it every 2 seconds, and if we get the heartbeat successfully, we're turning on a bit. Okay, and that bit is basically node OK. We're calling it machine 1C online because that's a bit we're going to go ahead and turn around and send to OCS360. And then here's where we actually receive the data from the network. Okay, and this can be always on. All right, because receiving data from the network does not add bandwidth to the network. It just basically is copying data from internal memory into an area where you can access it. Okay, so we've got 12 words here, could be as many as 32, but we've got 12 words here coming into an array, CsCAN in 10, that's the name of the array. All right, so that's where the data is coming in. Again, because this is variable-based programming, we go to the program variable table. That's where the rest of our work is done. Okay, and we scroll down here until we get to this section of variables here. Okay, so this is our array, okay, where the data is coming in, right here. This is our array, and we're mapping it to R1101 through R1112 because there's 12 words. If it were 32 words, it'd be R1101 through R1132. And then we have our individual variables that we've created mapped to the appropriate locations within that bank of registers. Boom, we're done, okay? As long as we check the checkbox that says this data needs to go out over OCS360. Don't want to forget that step too. All right. So one last thing I'll show you, and that is under the hardware config, under the CAN configuration. Again, this is where we want to set, if we're broadcasting data, okay, we want to change this here to 8, let's say. We're not, but we could be. So I'm going to go ahead and change it now just so it's ready in case we start broadcasting data over the network. Why would this OCS360 Gateway broadcast data over the network? Well, if you want to take data that is subscribed from OCS360 and pass it back down to one of these CsCAN nodes, then you would be broadcasting data over CsCAN from your gateway. So that's why you might want to change that. My example here doesn't show data going back the other direction, but it certainly could be done. All right, so there we go. So that was just the configuration on the CsCAN side. And now let's see if it works. Here's our bench view again. You can see the machine is on. Let's go to OCS360 and take a look at the data here. All right, there's our latest telemetry. And look, there it is. We've got machine 1C data, okay, interleaved with our machine 4B data, okay? And they're, of course, in alphabetical order based on the name of the key or the name of the variable. Okay, so our machine 1C, machine on 1C is on. We can see that here. What if we go ahead and turn it off? Let's go back to the bench view and turn it off. Okay, now let's see the result in OCS360, and there we go. Because we had fast responses, remember I've got this set for 3-second updates. You can see that quickly turned off there. If I turn it back on within 3 seconds, we should see it turn back on again. There it goes. Okay, so everything's working over CsCAN as well. Let's wrap up for today by reminding you the requirements for OCS360. To check it out, you'll need Cscape 10.1 and firmware 17.1 for your Canvas or Prime OCS, and those are all available today. We talked about the fact that the micro OCS will in the summer of 2025, and you might be watching this on replay after the summer of 2025, so the micro OCS will be an option as well. Okay, of course, you're also going to need to have your OCS connected over the internet, through Ethernet, Wi-Fi, or cellular, or any other way you can connect to the internet. All right, and of course, you'll need an OCS360 subscription. All right, we have 3 different standard OCS360 plans, plus the ability to contact the factory for a custom plan for yourselves. And again, your choices between silver, gold, and platinum, and the primary difference between the 3 is in the amount of data per minute that you can push to the cloud, and that's either 250 variables a minute, 500 variables per minute, or 1,000 variables per minute. Okay, lots of ways to interact with Horner online on our website at hornerautomation.com, on our YouTube channel where you'll find us presenting a new video every week, Tuesday at this time. And then also you can interact with us on LinkedIn. We've got a training schedule active for the 2nd quarter and the 4th quarter, so sign up early and get your spot reserved. Several trade shows this year, the biggie being in May in Detroit. So be ready to check us out there in Detroit at the Automate show. We're in booth 7025. We're going to be showing lots of stuff there. It's going to be really exciting. I've been working hard along with the rest of my colleagues on getting our booth ready. And so we're going to have a lot to show you May 12th through 15th at Automate in Detroit. Okay, next week, we've got another topic to go through, not OCS360 related. We're moving on to our normal type technical topics, and we're going to be showing you a topic by request from a customer about using high-speed counter outputs with an OCS. So these are things like programmable limit switches, firing an output based on an encoder position, that sort of functionality is what we'll be talking about with high-speed counter outputs. So join us next week on April 1st for that. Okay, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so thanks again for joining us for this series on OCS360. We'll be covering other OCS360 topics as they occur over the next several months. But until next week, let's all get out there and do some good.